Hey guys, and welcome back to this class, Data Science, Deep Learning in Python Part 2. In this lecture, we're going to look at variable and adaptive learning rates in code. So if you don't want to type out all this code yourself, you can check it out from GitHub. It's github.com/lazyprogrammer/machine learning examples and go to the folder ANN class 2. So the relevant files for this lecture are mlp.py again. So we're going to use the same neural network that we used last time. And we're going to look at RMSProp.py. So we're going to compare RMSProp and basically a constant learning rate. So mlp.py is exactly the same. We're going to use the rectifier, since we know that does a little better. Okay, and so I'm going to walk you through RMSProp.py. So all this stuff at the top is the same as in the momentum lecture. Max iter, print period are all the same. I get the same data, so it's normalized 784 dimensionality data. Learning rate is the same. Regularization is the same. Last 1,000 points are the test set. We still use 500 as the batch size, still 300 hidden units. And we are still initializing our weights in the same way. So for number 1, constant learning rate, it is exactly the same as before, except there's no momentum. It's just regular gradient descent, and we're printing every print period, and we're appending the cost to an array so we can plot it later. So now RMSProp is a little different, and I would recommend as an exercise also implement AdaGrad and maybe exponential decay and compare those as well. We need a initial learning rate, and then we also need to store a cache for each of the variables. We also need a decay rate parameter and an epsilon. So I calculate the batches in the exact same way, do my forward pass. And so here's where the difference comes into play. So I get the gradient, which is the derivative of the cost function, and then I add the regularization term. I update my cache, which is decay rate times cache plus 1 minus decay rate times the gradient squared. So this is element by element multiplication. And so I do this for each of the parameters W2, B2, W1, and B1. And then I print every print period, append the log likelihood or the cost, and then I'm plotting both of these together at the end so that you can compare them. So let's run this and see what happens. Okay, so you can see that with RMSProp, I was able to start with a higher learning rate, and it converged much faster at the beginning. And it also happened to give us a better classification rate as well. Notice how it's a little more shaky though.